Howdy out there, YouTube. For today's question, I have this object on this incline plane, and it is being pulled up at a constant speed. The question is, how large a force parallel to the incline is needed? So one thing to keep in mind is, I just said this object is being pulled up at a constant speed. So with that being said, we can say the whole system is in transitional equilibrium. So as always, the first step would be to draw a free body diagram to see a relationship between all the forces acting on this object. And before I forget, let's say this angle right here is 30 degrees. So let's assume that's the x-axis, and this is the y-axis, and our object is located right at the center. So the first force which is acting on this object is the force of gravity pulling down on it. Let me use another color. Actually, the same color, but it's better. You have the force of gravity, let's call it W, which is pulling down on this object. The next one is the force of, let's just call this force P, the force of P exerted on the object parallel to the incline to pull this object up. So that force, let's call it P, is right here. There is another force acting on this object. So this object is resting on this plane and it's pushing down on it. We know that Newton's third law tells us that there is an equal and opposite force pushing back. So if that's the case, we have another force right here pushing back. That force is called N, and we call it normal force. And one thing to keep in mind is the normal force always is perpendicular to the surface. So that means this is a right angle right here. So these are all the forces that we have acting on this object right here. Let's find the component of W. This one is 30 degrees, so that means here is also 30 degrees. And the value of this vector, or the y component of W, is W cosine of 30 degrees, and the value of this guy is W sine of 30 degrees. One thing to remind ourselves is these two forces cancel each other out. Otherwise, this object would fly off this inclined plane. So, with that being said, we only have this force and this force left for our object. So, at the very beginning I said this object is being pulled up at a constant speed. And we can say that the whole system is in transitional equilibrium based on that. For a system which is in transitional equilibrium, we can say all the forces, sum of all the forces in the x direction has to be equal to 0. So what do we have on the x direction? We have negative w sine of 30 degrees. And then we have this one, which is p equal to 0. And in the y direction, these two forces are canceling each other out, so we don't need to write that right here. So now we can, from here, we can say P equals W sine of 30 degrees. And we know that W is equal to 600 newtons. 600 newtons times sine of 30 degrees is 1/2. That's equal to 300 newtons. So in order to be able to pull up this object at a constant speed, we need to have this much force exerting on this object. Thank you very much for watching.